We are doing the review for the upcoming exam. I'm going to go ahead and do 25. And we have F, and then we have G of 0. So you got to figure out first G of 0. And we know G of 0 is going to be 3 times 0 plus 1. 3 times 0 is 0 plus 1 is 1. So we know that G of 0 is equal to 1. Now we got to figure out F of 1. So F of 1 is going to be 1 squared, so it's 1. So we know that F of G of 0 is equal to 1. Okay, we're going to do 26. And 26, we have F parentheses G parentheses of 2. That's going to go into F. So I'm going to have to figure out G of 2. We know that the input is 2, so we have 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So now 7 is going to go into F, and it's going to be 7 squared, which gives you 49. So this will equal to 49. 27, we're going to go ahead and figure out G, and what's going to go into G is F of 0. So we're going to figure out first F of 0, which we know is going to be 0 squared. So we're going to go ahead and input G of 0 into G. So it's 3 times 0 plus 1. 3 times 0 is 0, so you're left with 1. So the output for this composition is 1. I'm going to go ahead and do problem 33 and 36. I'm going to find the inverse. So let me go ahead and write 33. So the inverse of 2, 1 will be 1, comma 2. The inverse of 3, 5 will be 5, 3. We have the inverse, and we have 0, negative 2, so it's going to be negative 2, 0. Of course, the next one is negative 1, negative 1. And the next one is 6, negative 4. For 36, you have P of x equals 5 minus x divided by 3. What you want to do is, instead of having P of x, you're going to have y equals 5 minus x over 3. And remember in class I told you had to switch the x and y. So you have x equals 5 minus y divided by 3. And at this point, you're going to solve for y. So you're going to multiply by 3, multiply by 3. So we have 3x equals 5 minus y. These 3 will cancel because 3 divided by 3 is 1. So you have 3x equals 5 minus y. You're going to subtract 5 from both sides. So you have 3x minus 5 is equal to negative y. And you notice that we have a negative 1 in front of the y, so we divide by negative 1. So it's negative 3x plus 5 equals y. For number 38, it says graph each function and its inverse on the same graph. So we have y equals x squared plus 2. So to find the inverse, we have x equals y squared plus 2. We're going to go ahead and subtract 2 from both sides. So you have x minus 2 equals y squared. Get the square root of both sides. So you have y equals the square root of x minus 2. What you're going to do is you're going to go ahead and graph the function itself. Here's a function. And make sure you graph this on graphing paper. Y equals x squared. And it's a parabola, so I'm going to go ahead and I made a mistake. What I'm going to do is I'm going to go back. And what I'm going to do is I'm going to add 2. So I'm going to graph it. Now I'm going to go ahead and graph the inverse square root of x minus 2. So when you take the test, you're going to have to graph the equation and its inverse. Now you notice you're missing the other half. So what you need to do is you also need to graph negative square root of x minus 2. And that's how you get the inverse and the graph. And what I'm going to do here is I'm going to go back to the problem itself, and remember that the way you write the inverse is like this. That's how you write the inverse. That is the square root of x minus 2. And of course, the equation is equal to x squared plus 2. Also, you can also include the mirror. In this case, the mirror is y equals x. And you can see that it's a reflection. 39, I'm going to go ahead and do 39 with you. So for 39, we have y equals the square root of x minus 1. So I'm going to write the inverse. X equals the square root of y minus 1. So you see how I switched the x and the y. What you're going to do next is you're going to add 1. You're going to add 1 to both sides. So you have x plus 1 is equal to the square root of y. So what you're going to do to both sides is you're going to square both sides. So you have y is equal to x plus 1 squared. So the inverse will be x plus 1 squared. I'm going to go back to my equation. The y equals here, the screen. And of course I'm using a TI-84. You can use Desmos if you want. So I'm going to go ahead and I'm going to type in the original function. The original one was the square root of x minus, common mistake, minus 1. And then we have negative square root of x minus 1. And then we're going to graph its inverse, which is parentheses x plus 1 raised to the second power. So I'm going to graph it. So there's the equation, there's the inverse. And if you want to see the mirror, what you want to do is type in y equals x. And you can see there is the reflection of this equation. So I'm going to come over here and that is the graph. I'm going to go ahead and do number 4, 5, and 6. So I'll go ahead and start with number 4. So we have number 4. The absolute value of 3x minus 6 minus 7 is equal to 14. Remember, like I was telling you in your lesson, you're going to add 7 to both sides. You have the absolute value of 3x minus 6 equals 21. You will always have 2 possibilities or 2 solutions. So you have 3x minus 6 is equal to 21, or 3x minus 6 is equal to negative 21. Add 6 to both sides. Negative 6 plus 6 is 0. So you're left with 3x. 3x equals 27. Divide by 3, and it looks like 1, but it really is x. So 3 divided by 3 is 1. 27 divided by 3 is 9. Okay, on the other equation, you're going to add 6 to both sides. Negative 6 plus 6 is 0. So you have 3x equals negative 15. Divide by 3. So x equals negative 5. So what you want to do now is you want to check. So you have, and I'm going to use a different color to check. So you have the absolute value, 3 times 9 minus 6 minus 7, and you want to check if that's equal to 14. 3 times 9 is 27. You have 21. The absolute value of 21 is 21 minus 7. So 21 minus 7 is 14, so that does check. The next one you want to check is negative 5, the absolute value, and I'm substituting 3 times negative 5 minus 6 minus 7. And we want to check if it equals 14. 3 times negative 5 is negative 15 minus 6, which gives you the absolute value of negative 21 minus 7. And that does equal to 14. That does check. Okay. So your answers are 9 and negative 5. The next one I'm going to go ahead and do with you is 3 times the absolute value of 2d minus 1 is equal to 21. The common mistake here is to apply the distributive property, but you can't. You have to divide by 3. So you have the absolute value of 2d minus 1, and 21 divided by 3 is 7. So this is the form that you wanted. Now you can go ahead and say 2d minus 1 is equal to 7, or 2d minus 1 is equal to negative 7. You're going to add 1 to both sides. So you have 2d is equal to 8. Divide by 2. So we know that d is equal to 4. The next one you're going to go ahead and do, you're going to add 1 to both sides. So you have 2d, and negative 1 and 1 cancels. So you're left with negative 6. Divided by 2. So d equals negative 3. And what you're going to do now is check in the original equation. 3 absolute value, 2 times 4 minus 1. And you want to see if it comes out to be 21. 2 times 4 is 8. 8 minus 1 is 7. 7 times 3 is 21, and that does check. The next one you want to check is 3 times 2 times negative 3 minus 1. 2 times negative 3 is negative 2 minus 1 is negative 7. 3 times negative 7, absolute value negative 7 is 7. And that's going to be 21, and that does check. Okay, we're going to go ahead and solve number 6. Number 6. So we have the absolute value of 2v plus 3 minus 6 equals 14. Remember what I told you, the first step is to add 6 to both sides. So you have the absolute value of 2v plus 3 equals 20. Now you can go ahead and set it up. You have 2v plus 3 equals 20. And you have 2v plus 3 equals negative 20. You subtract 3 from both sides, and you notice that you're going to get a fraction. 20 minus 3 is 17, divided by 2. So we know that 16 divided by 2 is 8. So this will be 8.5. We subtract 3 from both sides. So we have 2v equals negative 23 divided by 2. So v equals 11.5 negative. So what you got to do is you got to go in your calculator and check this. So what I'm going to do, I'm going to go ahead and check this out. Okay, so I'm going to go ahead and show you how you can do it on the calculator. If I can get it on. Okay, so I have it on now. Mode, calculate, math. I think it was math. And then we go to number, then we go to absolute value, and we're going to type in 2 times 8.5 plus 3 outside minus 6, and that does check. It's 14. You can see that. So go to math, absolute value. You go to number, absolute value. So I have 2 times 11.5 plus 3. Of course, outside the absolute value, you got minus 6. And does it come out to 4? Oh, it does not come out to 14, but you'd want to double check here. It's negative 20. Oh, it was negative 11.5. So let me pull this out again. I found a mistake. So it's going to have to be negative 11 over here. And I'm trying my best to insert that negative. And let's see if that makes a difference. And the reason why I had to insert the negative, because remember, a negative divided by a positive is negative. I forgot my negative. That's a mistake that people often do. So I'm going to press enter. Oh, it does check out to 14, so it does work. I'm going to do number 16. So we have the absolute value of negative q plus 4 divided by 5 plus 1 greater than 2. So remember, you first have to subtract 1 from both sides. So you have the absolute value of negative q plus 4 divided by 5. 1 minus 1 is 0. So you have greater than 1. Now you're able to remove the absolute value sign. So you have negative q plus 4 divided by 5 greater than 1. And that's going to be or negative q plus 4 divided by 5 less than negative 1. So what you're going to do is you're going to multiply both sides times 5. So this 5 divided by 5 is 1. So you have negative q plus 4 greater than 1 times 5 is 5. You subtract 4. So you have negative q is greater than 1. Divide by negative 1, and you notice when you divide by negative, the inequality is going to change. So it's not greater than, it's less than negative 1. Okay? And you're going to do the same process on the other inequality. Times 5 times 5. The 5 divided by 5 is 1. So you have negative q plus 4 less than negative 1 times 5 is negative 5. You subtract 4 from both sides. So you have negative q is less than negative 9, but when you divide by a negative, the inequality is going to change. So instead of less than, it's greater than 9. So let me go ahead and go over here, and I have 9, and I have negative 1, and I do have a 0 here in the middle, not drawn to scale. Any number that is greater than 9 will go to the right. Any number less than negative 1 goes to the left. The only time that anytime that you will have a closed circle is when you have an equal sign. And remember, the arrow keeps on going in either direction because we're talking about more than one answer. I'm going to do number 17. And you notice you have a fraction that's right here next to the absolute value. Remember, before you could remove the absolute value, you have to multiply by 4. Multiply by 4 because 4 divided by 4 is 1. So you're left with the absolute value of x plus 2 less than or equal to 1 times 4 is 4. So you notice that we multiplied 4 to both sides, and so we're left with the absolute value of x plus 2 is less than or equal to 4. So now what you have is your possible answers is going to be x plus 2 less than or equal to 4, x plus 2 greater than or equal to negative 4. And I know everybody here in my class can solve this. You're going to subtract 2 from both sides. So you have x is less than or equal to 2. You subtract 2 from both sides. So you have x is greater than or equal to negative 6, and we know that that's going to be 0. That's 0. So I'm going to go ahead and draw the inequality line. So we have our solutions here. Circle, circle. So we have less than 2, greater than negative 6, and so your answer will consist of all the numbers between negative 6 and 2. That's going to be your answer, all the numbers between negative 6 and 2. I'm going to go ahead and do number 18. So I have 4, absolute value, 5z minus 8 divided by 2 plus 1 less than 9. And before you go any further, before you start writing your answers, you have to first subtract 1 from both sides. So you have 4 absolute value, 5z minus 8 divided by 2 less than 9 minus 1, which is 8. Our next step is to divide both sides by 4. So we have the absolute value of 5z minus 8 divided by 2 less than 8 divided by 4 is 2. So now that we have the absolute value by itself on the left side, we can go ahead and write our both solutions. So we have 5z minus 8 divided by 2 less than 2. And the other one is 5z minus 8 greater than negative 2, and it's divided by 2. And I'm going to go ahead and move this a little bit to the left. So now what I need to do is multiply both sides. I need to multiply both sides by 2. And you notice that these two are going to be 1. So you have 5z minus 8 less than 2 times 2. That's not 2.2. It's going to be 2 times 2, which is 4. You add 8 to both sides. The negative 8 plus the 8 cancel or become 0. So you have 5z is less than 12 divided by 5. So the first answer is going to be z is less than 2/5, so it's 2.4. Okay, so you're going to also do the following on the other inequality. You're going to multiply by 2. Of course, these two cancel. So you're left with 5z minus 8 greater than negative 4. You add 8 to both sides, and you have 5z is greater than 4. Divide by 5. And so we're going to have z, and I'm going to move it over a little bit. I have z greater than 0.80. So if I did my number line, my number line is right here, and I have 0.8, and let's say this is 2.4. We know that it's going to be less, so it goes in this direction. I know 0.8, it says 0 is greater than 0.8, it goes in the other direction. There's no equals, so you're going to have an open circle. So the answer is going to be between all the numbers between 0.80 and 2.4.